Hi everybody, today we're going to talk about the volume of prisms and cylinders. In the background you'll hear some dubstep music, Let It Go. It's a remix on Disney's Frozen. Just something different. So today, you already have a lot of background information on prisms and cylinders. What is volume? Volume is the amount of 3D space that an object can hold. Pause the video and make sure you know that. 3D space is the amount of space something can have. So mass, prisms, they are things that have two identical ends. They're 3D shapes with two identical ends. So if you think of triangles, you would just draw two triangles and then connect the vertices. You have a triangular prism. If you have a hexagon, 6 sides, draw another one, 2, 3, 4, 5, 6, and you connect their points. I should have done this a little further apart. You get a hexagonal prism. You have cubes, and cubes are basically a square prism. Square is the face. And you also have rectangular prisms. So two rectangles are your bases, and your faces are connected. So here are some real-world examples. You have the Rubik's Cube. We have the Toblerone bar. You have the pyramids, are triangular prisms. Also this building. Prism as a light refracts, reflects. We have a hexagonal prism right here. In this hex nut, it has a cylinder missing. And buildings also have prisms in it. This is a rectangular prism right there. So those are some real world examples. Now cylinders, they have two identical ends that are either circles or ovals, and they have straight parallel sides. So if you were to see a cylinder, and if you were to cut the tops off, let's say we wanted to do the net, cut the tops off, and then if you unwrap the inside, you would have a rectangle. So this shape right here is a rectangle, and your bases are circles. Here are some real-world examples of cylinders. Flashlight, hex nut right here with the circle cut out, the cylinder cut out. We have motorcycle engine that runs on cylinders. Machinery part, can of Coke, the Leaning Tower of Pisa. We have a coffee cup and a pencil. Those are just some real-world examples that I found. Now this is very important. You need to know this formula to find volume. It will be on your MCA and all your standardized testing, but you need to know that this big B stands for something different. It stands for the area of the base. So that's already a two-dimensional unit because it's squared. Then you take it by another dimension to make it 3 dimensionals total. We'll be practicing with that. To get set up, you need to pause the video. You need to have a pencil, color pencil or highlighter, paper, and calculator. Ready to rock. Okay, so what I did right now is I took my highlighter and pencil and I colored in the base because that's what you need to focus on first, big B. Now I think, what shape is that? Well, that's a rectangle. How do I find the area of a rectangle? And you say, self, that's A equals BH. So to find the area of a rectangle, I take the base and the height, and I'm just using the sides that touch my color. So I have 12 and 5. Ignore the 3. It's silly right now. You don't need it. And 12 times 3 is equal to 60. So 60 feet squared is the area of your base. That's what you're going to plug in right here for base. So I have volume equals big B. What is the area of that base that I just colored over there? It was 60 square feet. So I'm taking 60 and multiply the height that is not used yet. The height of my prism is 3. When you multiply 60 times 3, you get 180, and you label it in feet cubed, or cubic feet. Capital V always has a 3. Capital V always has a 3. Pause the video and get ready for the next one. Now in this case, when you shade the base, you have a circle. So think to yourself, how do I find the area of a circle? The big base is a circle again. So how do you do that? A equals pi r squared. So the area is going to be 3.14 times 4 squared. I don't know if you've gotten this down yet. 3.14 times 16 may be automatic to some of you. You get 50.24 inches squared. That number is going to be substituted in for your big B because, again, the base is the area of the base. So now that I found the area of this base, to get the volume, I need to multiply by the remaining height in order to fill this entire shape. Volume is how much space something can take up. So I substitute the area of the base and multiply it by the height. So when I do this, I get an answer of 452 and 2/10 cubic inches. Pause the video, let's go to the next one. So the first thing I do when I'm looking at volume, I first isolate the base. Once I figure out the base is always the same, has 2 sides that are the same. Now this one has 6 sides that are the same because it's a cube. But I just shade in a base and I ask myself, how do I find the area of that shape? It's a square, so I do base times height, or side squared. I get 6 times 6, which is 36. Sorry, I should show my substitution. And 36 inches squared is the area of my base. That's going to go in for big B. So my volume, V, equals 36, and I multiply it by the remaining height. So to fill up that space, I'll need to multiply it by a 6. So my volume is 216 inches cubed. Whenever you see a V, you need to put a 3. Next example here, you have a triangle, and you want to use the one that hits at the 90 degree. It doesn't really matter, but that's where your measurements are. So that's my base. If my base is a triangle, I need to find the area of a triangle. And the area of a triangle is 1/2 base times height. So these formulas are so important to know. Now the base in this case is not a big B, it's just the two numbers that touch at 90 degrees. So I'm going to use the 10 and the 8. And remember again, when you are doing bases, to always use the numbers that touch the side that you colored. Otherwise, you might get some funky looking answers. So you get 5 times 8, so your area is going to be 40 meters squared. And then when you find the volume, you substitute that in for big B. So what that goes in here, the volume will be 40 times the remaining number that's left over to get the height of your prism. You do 40 times 3 for a volume of 120 cubic meters. Whenever you see a V, you need to have a 3 cubic space. Next example, you want to pick the sides that are the same. So in order to have a base, it needs to have two faces that are exactly the same. So the two faces that are the same here are not on the bottom, but on the sides. So you need to color this side in, and then you need to find the area of a triangle. Because it's a triangle, we need to do 1/2 base times height. Now notice I substituted the B, the big B, for A, because big B stands for the area of the base. You could do this right off the bat. So you get 1/2 times 4 times 4, which is 8 inches squared. So when you substitute the big B back into the formula, I put an 8 here for the base. The number that's remaining is a side I have not used yet. So I take 8 times 14, either in my calculator or on paper, and I get 112 inches cubed, because whenever I see a V, I need to have a 3. It stands for cubic units. This is a cylinder. It's laying on the side, so don't that fool you. In order to have a base, it has to have two that are the same. So this is a circle. So my base in this case has a different formula. To find the area of a circle, I do pi r squared. So 3.14 times 3.4 squared. And if you put that in your calculator, you get 36.2984. So my volume will be that number, 36.2984, multiplied by the number that's not yet used. So you're like, "Hi, Reinhardt, that's not standing up." But it's the number that hasn't been used yet. So I multiply that by 12, and I get an answer of 435.5808, and my unit is feet. And I'm finding volume, so I have squared times normal, so I get 3-dimensional space. This next one's a word problem. Before you have the word problem, you want to draw yourself a picture. Go for it. You have a can that's 4.5 inches high. The diameter is 3 inches. So the radius would be half of that. Radius is half, which would be 1.5 inches. We want to use 3.14 for pi, and I find the area of the base first. That's a circle. So the area of the base will be pi r squared. 3.14 times 1.5 squared. Pause the video and see if you can do the math. Okay, so you should have gotten 7.065. Now substitute that back in for B and then multiply by the height. Pause the video, please, and then check your answer. Now checking your answer here, I did something wrong. Can you check and find my mistake? When I substituted in, I made a mistake of putting a 3 in for my diameter instead of the 4.5, which I should have put it in for my height. So if you did 4.5 the first time, you're right. So you get a final answer of drum roll please, 31.7925 cubic inches. This last problem is a telephone pole, pretty sky, isn't it? It's 30 feet tall. So you always want to draw yourself a picture. So this is a telephone pole, it is a cylinder. It's not perfect. Let's just say it's going down here. Pretend that there's wires going across the sky. They are 30 feet tall, and it has a diameter all the way across of 12 inches. Now, before you start, do these labels match? No. So we want to change that 12 inches to 1 foot. So now I have feet and feet. I'm ready to roll. So I'm going to change that to 1 foot. If the diameter is 1 foot, that means the radius is a half a foot, or 0.5. Now I need to fill it in with my information. And he wants to use a replica of this model. He's going to make it 30 inches. So I'm going to change mine to be 30 inches. I'm doing a replica. I'm trying to find the volume of his model, not the real thing. So my volume is going to be the area of the base times the height. In this case, my base is a circle, so it's pi r squared. I'm using the replica information to get his radius. He wanted a half, so a half of an inch. So 1 inch would be the diameter, a half of an inch would be the radius, so 0.5 squared. 3.14 times 0.5 squared is equal to 0.785. That's the area of the base. So I plug that information back in here. That's in inches squared. My volume will be 0.785 multiplied by the height. He has a 30-inch model. So his final volume is 23.55 cubic inches. That's his answer. Now, in the real world, that means instead of inches, we just did change the label. So in the real world, a telephone pole of that size would have 23.55 cubic feet. So think of about a foot. Your paper is about a foot wide and foot long and foot deep. So 3 different dimensions, and then 23 of those stacked on top of each other. I bet it's actually bigger than that in real world. I just thought this picture was cool. Make sure you use the formula volume equals base times height. Remember to label your volume in cubic units, whatever your unit is, and may the volume be with you. Get it? Takes up space.